Okay, so last night I was trying to fix this problem that I was having. In my last video I uploaded, I had done sort of a hello world program and got the initial audio working, the demodulator working, but it actually wasn't coming through correctly or clearly. And the reason for that was because I had a mismatch in sample rates going through the system here. So I didn't go back and look. I'm not exactly sure where the mismatch was, but it's important that your sample rate in and out of each of these blocks is consistent. So I do remember what I had last night was a 5 megasamples per second source rate. And then I was decimating that by 20 in the low pass filter for 250 kilosamples out, going to the wideband receiver at 250 kilosamples. And then something in this rational resampler was messed up. And I was getting an output rate that was different from my audio sync rate. And so that was not sounding good or correct. So I went back through and I was just following a guide for how to do this. And somewhere along the way, I got that messed up. So I was able to fix that. I was also able to do some optimization. So let me show you something here. If I run this program, and we'll hear the audio in the background as we're doing this. You can see here my receive bandwidth is about 8.4 megabits per second. And if I go to performance here and look at CPU, Python, which is the underlying layer that's running this, is running at about 12% of my CPU usage. So that's great. Higher than I would like, but still okay for considering what I'm doing. Now that's running at 250 kilosamples per second. What I was doing last night, I'm going to stop this. I'm going to change it back to something that I was doing. Oops, not here in the sample rate. I change this back to 5 million, which is what I was doing last night, and then change this decimation to 20. I still get an effective sample rate of 250,000 because I am sampling at 5 million samples per second, but then I'm decimating that by 20. So I get 5 million samples coming in here, and I get 250,000 samples coming out. But if I run this, you can see what will actually happen. I'm going to pull up my task manager again here. First off, one thing that's happening is I am receiving that data at full rate. So you can see here 163 megabits per second. Another thing that you can see is that my CPU is being essentially monopolized by Python. This is jumping around, but you can see my CPU usage is almost completely utilized, and Python is a huge percentage of that. So I think that is actually degrading the audio signal. I don't know, it probably does some type of like sample dropping or something when it can't meet the either network bandwidth or CPU specifications that you're telling it. It's going to obviously degrade the performance of the system, and then you're going to get sound issues that we're having. So I'm going to take this back to what it was. Keep doing that. Sample rate. 50. I'm going to turn decimation off here. And then rerun this, and you can see that my CPU usage goes way back down to somewhere around 12%, and then my network usage goes back down to just over 8 megabits per second from what it was 163 or something like that. A couple things I learned. One, go figure, the rates and the samples per second that you have moving through the system matter. And then two, you can definitely optimize for computing resources by changing your sample rate to the minimum that's sufficient for your application. So obviously for an FM radio station, they're only 100 kilohertz wide on either side, so 200 kilohertz total. And so even 250,000 samples per second is more than enough to capture the signal. And we get these beautiful plots. You can very clearly see the spectrum of the signal and the time domain also. And then some nice waterfall plots at the audio frequency and also at the RF frequency. So it's been an interesting learning adventure here, and looking forward to continuing. Thanks a lot.